Here it comes.
Yo, assalamu alaikum wa rahmatullahi wa barakatuh, and welcome back with another MEL science video. It's been a while. Here I'm your host, Jakishan Al-Arab, and in this video we're gonna be doing But Will It Burn kit. But will it burn? We're gonna be doing two experiments in this video since they're really short. The first one will be fire foam, and the second one will be igniting iron. So without further ado, let's start. So what we want to quickly prepare in advance is matches or a lighter, just anything that can be used to light up whatever we're going to do. Because I forgot to tell you, we're going to be playing with fire in this video. So yeah, it's going to be an interesting one. But anyways, let's first start with the starter kit. And we're going to take the famous plastic tray, the flask and the funnel, safety glasses, rubber stopper with one hole, and the glass beaker. I shall put this aside now. Now from the set, we're going to take a double-ended measuring spoon, a wooden splint, some gloves, a pin opener, and now we have something new, a metal cylinder, some silicone tubing, some liquid soap, some magnesium strips, sodium carbonate, and sodium hydrogen sulfate. Okay, now let's actually start the experiment. I'm first going to get my glass beaker and some liquid soap, and I'm going to pour the whole packet of liquid soap into this glass beaker. But first, let me set up this camera. So here it goes, and bismillah. Whoa, what a weird color. Ooh, it smells so good too. Okay, so basically my dumb self forgot to record on the phone, so yeah, I just poured soap, and this is how it looked like. It smells very good, and it's orange color. But let's move on. And now I'm gonna pour water to the 100 milliliter mark. Bismillah. There we go. Wait, I forgot to move this. But now I'm gonna take the rubber stopper, and I'm gonna put the metal cylinder inside of it. Okay, this is really hard. I don't know how much I'm supposed to insert it in, but I guess that will do. Now I'm going to take the tubing and insert it inside of the metal cylinder until it's almost touching the stopper, or I guess touching in this case because I think I inserted mine too much. And I'm going to take the other metal cylinder and insert it into the other end of the tubing, as so. Now I'm going to take the flask and the funnel, and I'm going to pour water to the 40 milliliter mark, or just to the 40 mark. And now I'm going to add 1 bottle of sodium hydrogen sulfate. Bismillah. Oh my god, it's sticking together. And now I'm going to swirl the flask for 1 minute. There, my timer's done, and now it's fully dissolved. And I'm going to add 2 big spoonfuls of sodium carbonate. 1. Whoa! And 2. Okay, it's fizzing. And I'm going to take 3 strips of the magnesium and put them into the flask. So here I have 3 magnesium strips. I mean 4, but it's supposed to be 3. Okay, so 3 magnesium strips. Going to put it into the flask. Okay, and it's fizzing already. And I'm going to close it with a stopper. Put the free end into the flask. Whoa. And we're going to leave it for 1 minute. Whoa, this is so cool. Okay, my time is now up, and now I'm going to take out my gloves, and I think I'm going to remove this now. I don't want to breathe it, I hope. Inshallah, bismillah. But now I'm going to move this a little far. Gonna have it like this. So what I'm going to do is I'm going to take my wooden splint. I'm going to light it on fire. Okay, it's on fire. And now I'm going to ignite the foam. So it's going to produce a loud bang. And I'm going to try this, so I'm kind of scared. Okay, bismillah. 3, 2, 1. Whoa, okay, wait. That was so cool. That was so loud. That was louder than I expected. This was so cool. Yeah, now what? I guess that's the end of the experiment. That was the end of the experiment. This was super cool. My heart stopped for a second. But now we're going to move on to the second experiment, which is going to be called igniting iron. Yeah, igniting iron. So I'm going to put all of these away, and then we're going to start with the second experiment. Here's the scientific description. Foam is composed of bubbles. Bubbles of most of the foams you come across in everyday life are filled with carbon dioxide, such as the foam in a carbonated drink, or a mixture of gases, or ordinary air such as a foam in the bathtub. Neither air nor carbon dioxide burn. That is, the oxygen in the air does not react with other components of the air, and carbon dioxide is even used in some fire extinguishers to the opposite effect. Not all gases are quite so tame. Hydrogen gas loves to react with oxygen, and even a tiny spark can initiate this reaction. In other words, hydrogen gas burns really well. In a sense, many chemical reactions are quarrels between different elements about who gets more electrons. In this experiment, hydrogen ions easily drag electrons away from magnesium, newly equipped with electrons. The hydrogen atom bonds in pairs as H2 molecules, which form the gas that fills the foam bubbles. Hydrogen isn't the greediest element of them all. The oxygen in the air is extremely keen to take electrons from others, and H2 is fair game. Even a spark or a glowing splint can initiate a reaction in which oxygen snatches electrons from H2. A stable compound forms, with oxygen keeping a strong grip on the electrons from two hydrogen atoms. Since this compound has two H and one O atom, its formula is H2O, also known as water. Okay, now moving on to the second experiment. We're going to start with the starter kit. So first, I will get my safety glasses, which I'm already wearing, and the plastic tray, and the pocket stove. Yay! So I'm just going to open this up, just like that. Very easy. From the kit, I'm going to put on my gloves and some iron wool or steel wool. For this experiment, I'm going to dim the lights a little bit, but before I light it, I'm going to have all the lights on, but when I light it, we're going to dim the lights before we light it. I'm going to move this pocket stove aside, but I'm going to take the piece of this steel wool and I'm going to part it carefully. I hope I did this right. And I'm going to get the pocket stove, place a foil at the bottom, and I'm going to apply a thermometer sticker to the wide part of the stove, just so I know when it's hot. And I'm going to place the iron on this foil. Now, I think it's time to take off my gloves and dim the lights. And I'm going to get my splint and light it on fire. And now I'm going to light our steel wool. Bismillah. Here's a scientific description of what's happening. Rails, nails, and other objects made of iron are not exactly easy to burn. It may even seem that iron is not flammable at all. But you just saw some fine iron threads burn quite well. What's the secret? As it turns out, iron burns just as fine when it's hot enough. But heating a big chunk of metal isn't easy. Most of the heat is quickly absorbed by the bulk of the metal. Fire threads of iron wool, however, do not have much bulk to them. Heat quickly accumulates in one place, making the iron react with oxygen, in other words, burn. This process produces even more heat, which further intensifies the process. You may have noticed that the burning iron wool didn't produce any flames. That's because iron doesn't release as many tiny glowing particles as an object like burning paper. Burning paper is constantly shedding carbon atoms, which eventually bind with oxygen to form CO2 gas, making what's left of the paper lighter. Iron atoms, on the other hand, stay where they are and oxygen binds to them instead, making the wool heavier. But anyway, yeah, this was it for this little experiment. I don't know if you want to call it an experiment. It was still pretty cool. And this will also be the end of the video. Wait a second. Okay, that's better. Yeah, so this will be the end of the video. I hope you guys enjoyed this video. This was very fun. We got to play with some fire and it was quite a lengthy video, but it was all fun. And I'll see you guys in the next video. We have a bunch of kits, so stay tuned for those. I'll see you in the next one. And assalamu alaikum wa rahmatullahi wa barakatuh.